We are Group 5 and we will be presenting our transportation model that we have devised in order to help bridge the gap between Caterpillar and part dealers. Here are the team members that developed these recommendations and we hope you find them useful. In this presentation, we will first give a short overview, then touch upon our methodology and analysis in going about the problem, as well as provide additional recommendations before moving into the final review. When reviewing Caterpillar's current situation, the main issue seems to be the lack of transparency between Caterpillar and the customer-facing dealers in determining mode of transportation when placing part orders. In order to go about this, we wanted to develop a standardized tool that will recommend the optimal mode of transport and help increase flexibility and visibility into the ordering process.
Keeping these tasks in mind, we came up with action items to create a model. We first determined metrics that most reflected criticality of a part. We then created a scale assigning point values to a chosen range. And lastly, we used those points to assess the degree of criticality and an appropriate mode of transportation. These are the 4 metrics we thought reflected criticality of a part. Lead time is a metric because it impacts how soon a part can arrive at the store to replenish stock so sales can be made. The second metric is days before stock out. This information we calculated by dividing on-hand inventory by daily demand. This is essential because we want to make sure there is enough inventory on hand before the shipment arrives so the target service level can be reached. We also included a demand volatility metric because it reflects how uncertain demand is, and variations in demand can result in unfulfilled orders decreasing service level. This was derived from the 12-month demand from the last year, divided by 365, and compared to the forecasted demand for the year. Lastly, target service level was the 4th metric because mode of transportation affects whether parts are in stock to fulfill orders so that there are no stockouts reaching their target service level. After determining our metrics, we created the criticality scale to be low, moderate, or high and assigned point values to these different levels, 0 being low criticality, 3 being moderate, and 5 being high. We then chose ranges we thought reflected the degree of criticality for each of the metrics. Target service level is a little different in that it can only be assigned 0 or 3 points because 90% of the target service levels are over 97%. We wanted to weigh this metric less than the others because we do not think that a 97% target service level reflects high criticality, whereas the 5 points for the other metrics do reflect a high criticality level. For the total criticality points, we determined 0 through 12 should suggest surface mode transportation because 12 and below is moderate in all 4 categories or yields low criticality. Therefore, surface transportation is appropriate. We chose 13 and up for air transportation because that accounts for 3 of the 4 metrics having moderately high or high criticality. This ensures emergency orders can be covered in the model, so air transportation is necessary in that case. Next, we are going to explain how the model works.
Now to see how this model actually works. We have designed this tool to be very automated and user-friendly, so dealers can simply input their store number and the part number they are looking to purchase. Once this is done, the tool uses the SUMIFS function to locate the previously mentioned metrics within the SKU data tab and return the correlating values directly from the SAP report. Using if-and functionality within Excel, each of these data values is then awarded the appropriate number of criticality points as specified within the legend. Using these points, the report sums the results from all 4 metrics to determine the total criticality points earned, which is then used in recommending shipment via air or surface. As you can see, this particular example earned 14 points in total, which would suggest this is a fairly critical part and would be suggested to ship via air. When comparing the total cost per part to ship for both methods, we can see there is only a 34-cent difference per part in price, so air remains a reasonable choice.
So of course we have some assumptions and limitations with this model. Our first assumption was that accurate average daily demand can be derived from the previous 12 months demand given in the data. Additionally, we assume the difference between forecasted demand and the previous year's actual demand was an appropriate indicator of demand volatility. Our final assumption is that customers allow a reasonable delivery period for non-stock, non-emergency parts. One of our limitations is that we had no data on actual service level to see how the stores are currently performing. Also, we do not know the selling price, which would be very helpful in analyzing the potential losses of a stockout. Finally, the data given was only a snapshot in time, and metrics such as on-hand inventory constantly change. So ideally, this model should be linked to an inventory system so it reflects the most current levels. Over time, the model and the analysis within it will have to be updated. The model should always contain the most recent forecasted demand, so as monthly forecasts are adjusted to be more accurate throughout the year, the model should update as well. Cost savings should be evaluated after 6 months of use to ensure the model is adjusting the most appropriate and cost-effective transportation mode. Additionally, all inconsistencies or issues with the model should be reported to managers to ensure timely bug fixes and software updates.
When using this model, it's important to note the time value of each transportation mode. The two options, air and surface, offer different advantages. When compared, air is the ideal method when the criticality of the product is high and when a shorter lead time is essential. This is the preferable method for emergency orders as lead time can be significantly reduced and air shipments can take a direct route to the destination. However, dealers are reluctant to use this method because the reduced lead time comes with an increase in costs. The other method is ground transportation. This route is the most cost-effective option and is the preferred method for shipments and replenishment orders. However, it is important to note that this option means longer lead times. If it is an LTL shipment, this can reduce the costs since you're sharing with other customers, but can also add time onto the trip because of frequent stops. When implementing this model, we have the following recommendations. As with all changes, there will be initial resistance to the use of this tool from dealers. To deal with any disruptions in service that may be caused by parts changing delivery mode, we recommend sending experts on the model to the dealers or having people from Caterpillar available to help dealers make the transition and decide which mode is best for them. This may include creating a new ordering process based on the findings within the model. This will help the dealers adjust buying models to fit the new modes. To manage network constraints when a large number of parts change these modes, we suggest using a test store as a way to forecast any large change in delivery. This may reveal a need to purchase more vehicles or to outsource some logistics. Another option would be to use demand-weighted distance to find the optimal routes between locations. Finally, we would recommend streamlining inbound and outbound shipments through a revised shipment schedule to fit the constraints and changes of the model. To communicate the criticality of the model to dealers, Caterpillar should first send out an important notice of the model's development, explicitly stating that the main purpose is to save dealers money on shipping. The simplicity of the model is meant to provide a transparent mode recommendation. Once the model is complete, Caterpillar employees should develop a video tutorial walking users of the model through the process. A feedback system would be necessary to review and make adjustments. CAT could hire employees who are experts with the tool to be available for support online or over the phone with the main dealers in the region. This way, dealers would feel included in the process and like their concerns are being heard. Eventually, when the model utilized in Latin America is finalized and its effectiveness is apparent, the model can be introduced to other regions of the world. A major factor that would be necessary to include in an expanded version would be distance to more accurately predict shipping costs. Additionally, there are so many different climates and terrains around the world that would need to be considered depending on the nature of the product as well as the transportation. The model may have to be adjusted based on the different needs and conditions in other areas of the world. To minimize confusion for Caterpillar employees, the tool could be introduced in phases based on region of the world. Caterpillar should utilize a model that incorporates lead time, days until stockout, demand volatility, and target service level. A video tutorial would be most helpful to train dealers to use the model, and Caterpillar employees must be available for troubleshooting. After receiving feedback from dealers, developers of the tool could make necessary improvements to the tool to make it more useful. Once the model is seamless in Latin America, it can be introduced in phases to other parts of the world. This concludes our presentation. Thank you for listening.